We're continuing to graph. So far we have graphed sine and cosine. We have also graphed tangent. Today we are introducing cosecant, secant, and cotangent. When it comes to graphing the reciprocal functions, the key things necessary for graphing them is knowing which of the trig functions they're the reciprocal of. Because the graphs for each of them are highly dependent upon the sine, cosine, or tangent graph. Cosecant's the reciprocal of which of the three main trig functions? Sine. Secant's the reciprocal of which one? Yep, cosine. Leaving cotangent to be the reciprocal of tangent. They are interrelated in the fact that that reciprocal piece tells us how to get from one graph to get to the other graph. Now, being reciprocals means that the typical period of the graph will follow based on the sine, cosine, or tangent. So cosecant's period will be the same as what sine's period would be for that function. What is sine's typical period? 360 or 2 pi. What about cosine? Same. What about tangent? 180 or pi, depending on if we're graphing in degrees or radians. And so far, we've really only graphed in degrees because we haven't needed to switch over to radians yet. So that means the typical period for sine, cosine, cosecant, and secant is 360 degrees, or 2 pi radians. For cotangent and tangent, it is 180 degrees or pi radians. They will go together. How you change the period for sine is how you change the period for cosecant. We've been graphing them. We've been kind of putting them in a y equals a times whatever trig ratio it is. I'm just going to write sine of b theta. Which affected the period, a or b? B. So if I have a function y equals, I don't know why I wrote a, sine of 2 theta, how did I find the period? 360 divided by that 2. I see a function y equals cosecant of 2 theta, I do the exact same thing. The graphs look significantly different though. The actual graphs for cosecant and secant especially look significantly different than the others. Cotangent will look similar to tangent, but it has some key differences. So we're going to start with a basic cosecant function, y equals cosecant theta. When we've been doing our graphs, once we introduced tangent, we ended up with 6 key things that we labeled that went with our graphs. What were they? Period, amplitude, midline, Eventually, domain, range. What was the newest one? Asymptotes. So, I'm starting off with the basic. Y equals cosecant of theta. If it's the basic one, it goes with its typical period, which is going to be 360 degrees. We're going to continue to work in degrees until we have to work in radians. Tends to be easier that way. Amplitude. By definition, half the distance from the maximum to the minimum. No, we haven't talked about the maximum and the minimum of cosecant yet, so we're not there yet. Midline, we're keeping at y equals 0. So, I'm going to jump to my axis already, because we know some things about how we typically label our graph. We know that if the period is 360 degrees, then on my theta axis on the far right side I put 360. On the far left side I put negative 360, and I divide the graph, each of those, into 4 parts, labeling every other, because each side represents one period of the graph. And when I graph these, I want to see 2 periods. And the key things that each of our trig functions do, they do at the quarter marks of the period. Now, when we have graphs like these ones, if this was a sine function, the amplitude would have been 1. And that tells us how we label our y-axis, or at least the way that I've said is the easiest way to label it, is to do double that number in front above and below the midline. Number in front is 1, double that is 2. We're going to continue to do that, regardless of what the amplitude is or not. We're going to take that number in front, double it, and that's how high you should go at minimum above and below our midline, which currently is still hanging out on the theta axis. We haven't moved it yet. Here is why we do it this way. One of the things you probably noticed is we haven't really taken advantage of having that extra height on our graph. You've only ever made the graph go, if it was sine or cosine, up to the amplitude, down to the negative piece of that amplitude. Cosecants and secant graphs take up that extra space. That's why I've had you give that extra space. That way we have a consistent way of doing it. Now, I've already mentioned that a cosecant graph is going to rely heavily on a sine graph. If this was not cosecant, if this was sine, because in all actuality it's the reciprocal of sine. If it was a sine function, where does the sine function start? Does it start at its maximum or at its midline? Starts at its midline. I'm going to switch colors for a bit, because it's not actually part of my graph that I'm going to draw. I'm going to draw things related to the sine graph on here. Note I'm not writing them on the active board, so I'm not saying you shouldn't write them down. Sine would start here. What would sine do next? Goes upwards as you go to the right. It would hit its maximum, which its maximum would have been at 1. After it hits the maximum, where does it go next? Goes back to the midline. After hitting the midline, it goes to the minimum, which would have been -1, and then it goes back to the midline. As I move to the left, it would have gone down to the minimum, back to the midline, back to the maximum, back to the midline. If I was graphing sine, I would then connect it. Am I graphing sine? No, don't do it. Don't connect them. we take the sine curve, sine and cosine, and we change them into cosecant and secant using facts about reciprocals. Sine's midline being at 0, its midline hits well, there's 0. What's the reciprocal of 0? You said it right. Reciprocal of 0 is undefined. What does undefined look like on a graph? Looks like something.
Straight line.
Quinn, what's it look like? It looks like an asymptote. Where sine has midline hits, cosecant has asymptotes. I do asymptotes in red. Where sine has midline hits, cosecant will have asymptotes. Where cosine has midline hits, secant will have asymptotes. Where tangent has midline hits, what will cotangent have? Asymptotes. Now we need to get the rest of the graph involved. Sine's maximum is 1. What's the reciprocal of 1? 1. Sine's minimum is -1. What's the reciprocal of -1? -1. The maximum and minimum hits of sine are parts of the cosecant graph. In fact, they're minimums and maximums as well, but they're the opposite. A maximum hit of sine is a minimum hit of cosecant. The cosecant graph looks like this. Where sine hits its maximum, it hits its minimums. Where sine hits its minimums, it hits maximums. And by maximums and minimums, I mean relative maximums and relative minimums. They're relatively high points, relatively low points, but they're not the highest point or the lowest point, which is what a true maximum or a true minimum is. Now it has relative high points and relative low points, relative maxes and relative mins. Does cosecant appear to have a true maximum? No, because it goes towards the asymptote, it goes towards infinity. Does it seem to have a true minimum? No. If it doesn't have a maximum and it doesn't have a minimum, it's going towards infinity, it's going towards negative infinity. Can I find half the distance between an infinity and a negative infinity? No, because you can't add infinities to get half of them. So, amplitude is undefined. Sine and cosine are technically the only graphs, trig functions, that have amplitude. Okay, asymptotes. Theta equals. We write out an equation. We write out the equation the exact same way we wrote out the equation for tangent. We start by telling the location of one of the asymptotes. Doesn't matter which one, just pick one. There's a lot of them. Sure, 180. I personally would have chosen 0. I'm going to go with 0 and I'm going to show you why. There is an advantage. If there's an asymptote at 0, there is something that can make it slightly less writing. Plus, how did we find the second number? Distance between the asymptotes. It's how you get from one asymptote to get to the next one. How far apart are the asymptotes from one another? They are 180 degrees apart because they are 2 ticks apart, and 2 ticks is 180 degrees. 0 plus 180k, where k is an integer. I said there was an advantage for 0, right? Do you really have to write 0 plus something? No. If you have an asymptote at 0, you could have just written theta equals 180k, k is an integer. How does asymptote relate to domain? It's the exact same thing, except not equals. If there are asymptotes, the domain is anything except for the asymptotes. Actually, I can rephrase that. The domain is anything except for the asymptotes, regardless on if there's asymptotes or not. If there's no asymptotes, everything that's not an asymptote is everything. Hence, sine and cosine's domain is all real numbers, because there's no asymptotes causing issues. At least this is true for trig graphs. Okay, range looks a little different. Range talks about how the graph goes upwards or downwards, making sure it hits everything in between. Would you agree that my graph goes infinitely upwards? Would you agree it goes infinitely downwards? But there's a gap in the middle. Unlike tangent and what will be cotangent, there is a gap in the middle of cosecant and secant graphs. That gap where the sine function lives, or the cosine function if you're working with secant. So my range, I have 2 distinct parts of it. I have the parts that have their relative minimums and go up, and I have the parts that have the relative maximums and go downwards. I have to write 2 different inequalities because of the graph having 2 different distinct pieces in what the range does upwards and downwards. These pieces are y's that are greater than or equal to whatever that relative minimum value is. In this case, it happens to be 1. So that's half of my range. The other half of my range is the y's that are less than or equal to those relative maximums for those pieces that go downwards. In this case, they are at -1. To graph a secant or a cosecant function, you look at what the sine function or cosine function would look like. Midline hits become asymptotes. High points go upwards, low points go downwards. Y equals -2 secant of 3 theta. Secant's the reciprocal of which one? Cosine. So we're going to think about the cosine graph. We're going to get some things on there that are from the cosine graph, and then we're going to change it into secant. One of the most common mistakes I see people make on secant and cosecant graphs is they lose track of what they're doing and they draw the sine function or the cosine function instead. So, make sure you're drawing the right one in the end. Okay, what's the typical period for secant? 360. What am I dividing it by? 3. What is 360 divided by 3? 120. Amplitude for secant, cosecant, cotangent, tangent are all the same. Should be an easy one. Amplitude will be undefined. Midline hasn't changed yet. Y equals 0. Asymptote, domain, and range, I come back to them. Go to my graph. Again, it's not a required thing that you actually label your axes this way, but it tends to be the easiest way to do it. And I do want to see at least 2 full periods, which is why I always label this way. 120 on the far right, negative 120 on the far left, divide into 4 parts on each side. How high and how low am I going on my y-axis? 4 above, 4 below, 0. Because the midline's 0. So double that number gives us room. Secant, we said, was the reciprocal of cosine. So we're going to get the important parts of cosine down and we're going to flip them around. Cosine, does it typically start at its maximum or at its midline? Typically starts at its maximum. Will this one start at the maximum? No, because what's this one doing? It's going to reflect. It's going to flip. Remember, when you do a flip, you got a maximum minimum switch going on. Putting that switch on the maximum or the minimum for cosine will take care of the flip for secant. So, instead of starting at its maximum, cosine's going to start at its minimum. What's cosine's minimum for this function? -2, because that's what the amplitude would have been. After hitting the minimum, where do you have to go? Midline. After hitting the midline, you go to the maximum, which is at 2. Midline, minimum. Follow the pattern across your graph. Do not connect them to make the cosine function. We are not graphing cosine. We are graphing secant. How do I change cosine into secant? Midlines are asymptotes. Midline hit, asymptote. Midline hit, asymptote. Midline hit, asymptote. Midline hit, asymptote. Okay, I got my asymptotes. How do I get the U shapes? Draw them where? Going what direction? Low points, the U's go what direction? Upwards or downwards? Downwards. Make sure the ones on the edge, you can tell that they're going down after you get beyond the graph. Not that it looks like it's going up. Low points go downwards, high points go upwards. Asymptotes theta equals possible first number? Someone other than Xavier who's answered most of my questions. 30. Is that the only possible number we could have put? No, we could have also put negative 30 or negative 90 or positive 90 or any of the others. If you want to be obnoxious, please don't be obnoxious. Plus, second number. Second number is distance between asymptotes. Asymptotes are 2 ticks apart, and 2 ticks has a distance of 60 degrees. 30 plus 60, don't forget the k, and telling me that k is an integer. Domain is everything except for the asymptotes. So the only thing that changes from asymptotes to domain is domain should say what? Not equal. Range. Should be broken into 2 parts because there's 2 distinct regions of what the y values do. They go upwards and they goes downwards with a gap in the middle. Y is greater than or equal to what number? 2. Y is less than or equal to what number? Negative 2. Cosecant and secant, all that different? No, you're taking your sine and your cosine functions, you're taking them a step further. Cotangent's going to look a little bit different, so we got to deal with it, but the bell's about to ring for lunch. So we're going to talk about cotangent after lunch, and for this. No, there's not. The bell releases sea lunch. Okay, so y equals 2 cotangent of 6 theta. Oh my goodness. I will likely not be there. What day is it even?
The 20th.
Oh, yeah, no. I cannot on Mondays. My husband has class on Mondays, so I have my daughter. Excuse me? Rude. Aubrey is wonderful and is not boring. Thank you very much. I meant my daughter, but anyway. Anyway, y equals 2 cotangent to 6 theta. What's cotangent's typical period? 180. What am I dividing by? 6. 180 divided by 6? 30 degrees. Amplitude we'll come back to because we haven't seen what the cotangent graph looks like yet. Midline, still y equals 0, and we'll get back to asymptote, domain, and range. Cotangent graph is basing itself off the tangent graph. So, I'm gonna write some things based on the tangent graph. Tangent typically starts where? The midline. Ooh, I forgot to label my y-axis. Don't mind me, I'm gonna do that quick. Anyway, tangent typically starts at its midline. So I switched colors again. We'll typically start there. How do I graph a tangent function? I got it start, and then what do I do? I need asymptotes. Where are the asymptotes located for tangent? Now, they happen to be at the 15s, but why are they at the 15 and the negative 15? Because they're halfway in between midline hits. And if it hits here, it's going to hit a full period later. That's how periodic graphs work. A full period later, it should be at the exact same place. Now, tangent would then typically have asymptotes here. We're not graphing tangent, so I'm not actually going to draw a full asymptote. I'm just going to be like, hey, that would be an asymptote. Midline hits for tangent, or we're going to do what for cotangent? Midline hits for tangent are going to do what for cotangent? We've already had this conversation. They're going to become cotangents asymptotes. Midline hits of the original become asymptotes of the reciprocal. So cotangent is going to have an asymptote here, here, and here. We know that because that's where our tangent graph has things going on. Our tangent graph also typically has asymptotes. Asymptotes occur where you have something that is undefined. What's the reciprocal of undefined? 0. Which means tangents asymptotes becomes cotangents midline hits. And now for what the rest of the graph looks like. What the rest of the graph looks like, I'm going to talk about, and I'm going to come back to the secant and the cosecant graphs and talk about why these ones look like this to figure out why cotangent looks like what it does. For my two graphs that I started with, this is what the sine and the cosine functions would have looked like had they had, well, this one was just a regular sine function, and this one would have been if you have, if you had negative 2 cosine of 3 theta, it would have looked like this graph. These graphs went up at maximums because they shared these points in common, because those points are originally 1s, and then they had the amplitude change them. And the reciprocal of 1 is 1, hence the reason that point existed on both the cosine and the secant graph. It exists on both the sine and the cosecant graph. But then, on my cosine or my sine graph, as I move away from those maximums and minimums, going in both directions, I start to get to numbers that are smaller, right? What happens to reciprocals as numbers get smaller? What happens to when you take the reciprocal of them? What's the reciprocal of 100? 1 over 100, right? Or 0.01? What's the reciprocal of 50? 1 over 50. In other words, 0.02. What's the reciprocal of 10? 1/10 or 0.1. The bigger the number, the smaller the reciprocal. As you take the reciprocal of bigger numbers, numbers get smaller. As you take the reciprocal of smaller numbers, the reciprocal gets bigger as a result. Hence the reason as this one goes down, this goes up. Why is that important? Okay, let's go back to where we were talking about tangent and cotangent. Bring this back over. The tangent graph, we already established would have had asymptotes there. Then the graph itself would have done this, and this, and this. As tangent is getting bigger, its reciprocal is going to be getting smaller. Would you agree that the moment I jump over tangent's asymptote, it is continuing to get bigger? Jump over the asymptote, it's continuing to get bigger. As you move from left to right, it continues to increase, which means tangent is an ever-increasing function where it is defined. Therefore, cotangent is an ever-decreasing function. A cotangent graph looks like a flipped tangent graph that's just positioned differently. Cotangent graph looks like this. It's got that half U flip over to get the other half of the U thing going. Tangent starts at the bottom because it has to increase. Cotangent starts at the top because it has to decrease. Amplitude, by definition, is half the distance from the minimum to the maximum. Does cotangent appear to have a maximum or a minimum? No, it goes towards infinity and negative infinity, and can you find half the distance between them? No, so the amplitude is undefined. I mentioned this earlier, actually. Sine and cosine are the only ones that actually have amplitude. Asymptote, theta equals, where should I start? If you start at 0, do you have to write it? No, but it would be 0 plus what? Distance between asymptotes is 30. K, where K is an integer. If there are asymptotes, the domain is everything except for the asymptotes. If there are not asymptotes, it's still everything except for the asymptotes, just happens to be everything. Theta not equal to 30K, where K is an integer. What's my range for a cotangent function? All real numbers. Goes all the way up, goes all the way down, there's no gaps in the middle. If you're going to write the fancy version, you're not writing theta exists within the reals, you're writing y exists within the reals. Because range is y values, not theta values. So, cotangent graph looks different, but still follows the key characteristics. When it comes to graphing our reciprocal functions, you get those key features of the original function on there, and you turn them. Asymptotes become midline hits, midlines become asymptotes, maximums become relative minimums, minimums become relative maximums, increasing becomes decreasing.